attempt. 7 and 3 are prime numbers. I can't present those with the same base. That's not possible. So my only chance is to apply log. Can you apply common log? Sure, you can apply common log. It'll be the same thing. Which log do you want to apply? I have to apply one of the two that I have in the calculator, either log or ln. For me, it's easier to write, these are 3 letters, these are 2, it doesn't matter. Really, the answer will be the same. You want to apply natural log or common log?
Natural.
Okay. 2 numbers are equal, their natural log will be the same. Now it allows us, but now you have to be very careful, because if you write like this, that is incorrect. You're not showing that the power is this if you don't put parentheses. So 2x plus 1 comes from the power of 7, and that's correct. And now this is x plus 2 in parentheses times natural log 3.
Real quick, when you put the log in front of the 7 and 3, that's you doing inverse, right?
Yes, we are applying the inverse function.
Okay.
Yes, of course, yes, thank you. Very good point, yes. So, like here, that's why I gave this side note for comparison. When we try to solve the square root of x equals 2, we have to apply the inverse function of the square root. Here we're trying to solve an exponential equation, and the inverse function of any exponential equation is some sort of log. So that's why we decided to apply log to both sides. Now I have to distribute. I distribute this number is just a number. I know it looks weird or fancy, whatever you want to say, but it's just a number that needs to be distributed to 2x and needs to be distributed to 1. Same thing here. So 2x natural log 7 plus natural log 7 equals x natural log 3 plus 2 natural log 3. So I distributed natural log 7 to those two terms. At this point, I realize that only 2 terms have x. They must be on the same side. And 2 terms do not have x. Well, they must be on the other. So when I move this to the other side, I will get 2x natural log 7 minus x natural log 3. And then the right hand side will be 2 natural log 3 and minus natural log 7. We are solving for x, so then what now? How do I solve for x? I cannot combine them, they're not like terms. When I try to solve for a variable and I cannot combine like terms, I have an alternative. What is the alternative? The alternative is, remember the 2 key words that should always be in our minds, in the back of our minds. These are the 2 key words that we have to keep in mind at all times. So, if we can combine like terms, then what can we do? Give it a try.
Simplify.
I can't. These 2 terms have a common factor. 2 natural log 7 minus natural log 3. And on the other side, 2 natural log 3 minus natural log 7. And that's final. Final what? How do I write the final answer? This is just a number that multiplies x must go to the denominator. And this is 2 natural log 3 minus natural log 7. So let's summarize what happened here. So we had to apply natural log to both sides because we needed to move the power in front. We did. Then we distributed. We did. Then we realized that the variable is in two terms, one on one side and one on the other, so they have to join. This one has to join the other one on the left, and this one has to move to the other side. So basically we separated two terms that have the variable from two terms that do not. At this point I wonder, what do I do? Because I need to solve for x. And I can combine these. I cannot say that this is something else. I can't. So the only thing I can do is just factor and then write 2 natural log 7 minus natural log 3. The other side is another number. I divide this by this because this is a linear equation now.
Can you turn those numbers back into exponential when you're done?
When you're back into exponential, you can. You can only write that this is natural log of 9, 3 squared minus natural log 7, so the numerator will be natural log of 9 over 7, and the denominator will be natural log of 49 over 3, and you cannot do anything because we don't have a rule for natural log A over natural log B. Oh, I'm sorry. There is no rule for this, so you will not be able to change it. If you want to approximate it, though, to check the answer, yes, that's a good point. So, parentheses around the numerator, 2 natural log 3, 2 natural log 3, close the parenthesis for natural log, minus natural log 7, close the parenthesis and close the parenthesis for the numerator. Now another parenthesis, divide, another parenthesis for the denominator, 2 natural log 7, close the parenthesis, and minus natural log 3, close the parenthesis for natural log and close the parenthesis for the denominator. Now when I press enter, I get 0.08997. So x is approximately 0.08997. If I want to check this, like we did before a few minutes ago, the equation is this, and better when you check your answer, better to use this. So I'm going to check in this equation, not in that, because I want the calculator to use the previous answer. Is that okay? So, 7, caret, in parentheses, 2 times the previous answer plus 1, minus 3, power, in parentheses, previous answer plus 2, previous answer plus 2, close the parenthesis. I want the calculator to use it all so I can get 0. Because otherwise I will not get 0. I will get, although the calculator may have an error or a tolerance, we call it. It may not give me 0, exactly 0. It might give me 0.0000000000001, which is 0. But let's see what we get. And we got 0. So indeed, this is the correct solution. But most of the time, we don't want it in an approximation form. We want it in the exact. So this is the exact answer, and you should not do anything else to it. It's done. And this is the approximation. Any questions? Any questions? Okay, we have 3 more minutes. We will not start the log equations. So log equations will be done on Wednesday, and the last section of chapter 4, applications, more applications of these functions. So we have time for, let's finish up with one more problem. You can choose if you'd like If not, I would like to choose problem 40. This is 3 raised to x over 7 equals 0.2. There is no way I can present 3 and 0.2 with the same base. Obviously, I have to apply log or common log to both sides. The power becomes a factor in front. My first step, I would like to get rid of this, multiplying both sides by 7. And as the final step, and it's done, what do I do? That's the very last step.
Divide by natural log 3.
That's it. Again, don't get confused with this ln.